So here we have the Bose CD LifeStyle Music System 5 with a faulty CD player. There's no CD working at all. So what you need to do is quickly just do, I'll just show you how to do this. I'm in a bit of a hurry today, but if you get the CD illuminated here with the disc symbol here, and then if you look down in the front corner of this board, there is the vane switch, which is an optical vane switch, which is the CD lid closed switch. Okay, so if we just pop that out, I'm going to put this into tele macro mode, and you'll see me moving this. I've just got a little plastic clip in there at the moment, but any opaque object which you can slot in and out will work. Okay, now if we go into tele macro mode, so there you go, you can see the CD pickup head there. There's this CD pickup head. Obviously, you're going, before you do any of this, check that the lens is clean and check that this, you can push that down, you can see it's floating nicely in the actuator. This is the focusing mechanism up and down to make the focus on the bottom of your CD. So now if we just whip this little blade out of the vane switch I showed you, I'm just taking it out now. You can see it does a little bit of reset, and when I put it back in, can you see that? It's doing its focusing thing. But there ain't no sign of any IR. If we turn the light off and do it again, we might be able to see it. Still no sign of any light from the thing. Let's turn this other light off. We'll get them in the end. We're in the dark now. Right, so no sign of any IR whatsoever, and I can just confirm that by putting this camera into night mode, which is on IR camera. So hold on, we'll go into IR mode and see if we can see anything at all. Alright, now we're on night mode, and we'll try it again, shall we? See if we can see any infrared coming out this thing. No, you can see it going in and out focus while it's tracking it, but no infrared. Alright, so that's just an interesting aside. There's nothing coming out of there. Normally it's about 780 nanometers, I think, and you would be able to see on the fringe of your response of your human vision the faintest red light, I think, on most, but not all. But yeah, so that's one way of checking it with infrared camera if you've got one, but you haven't probably. So let's go on to the next stage. So let's whip the CD drive out of here and have a look at it, shall we? So we need to get lifted up off the support pegs, and you'll see there's a number of connectors here, but don't pull them on the lead because you will pull the wires out. Basically, they're quite fine, some of the leads. And the way I prefer to do it, if I can find my tweezers, which is a big if, I found them actually, is just to go in there and just lever the connector out. You can see me doing it there, no stress. Just between the two pins and the body of the connector. That's one connector, that's the motor drive and the actuator drive, and there's two other connectors around here which need to come out, so just get hold of them with a pointy thing and leave them out. So say don't pull on the cables, it's a no-no. I'll also unplug the power, of course. Yeah, idiot. Finally this one. Right, so that's that one gone. Straight my tweezers, that was a bit more violent than I expected. Right, and so looking at this CD drive, we've got the back of this thing. You can see CD. I'll zoom in on that a bit and I'll just give you a quick tour of it, shall I? Right, on the back of this unit, you can see here we have the pickup, if I can find it. It's got stuck on there now. So here we have the pickup on the unit. There's the lens and the actuator, the coil actuators for the positioning of the head and the focusing. And then if we turn that over, you can see at perpendicular to the lens, you can see these three connections here, and that is the laser diode. And in that package there is a laser emitter diode for produce the probably 780 nanometers infrared, and a photodiode as well. So first thing to do if you've got no output is just to do a quick check to see whether you've got any shorts, whether the laser diode is shorted. And it is. Look, that's the laser diode connection. Notice that this could be rotated. In some CD drives this diode is around 180, so you're looking at the triangular leg pattern, and you can see I've just got this on diode forward voltage drop test on the meter, and the meter's reading 2 millivolts. It's a dead short. The diode is completely dead. And this one, the other one here, is the photodiode, and in that position with the positive on the common connector, that's the common connector in the middle there, I have no connection. If I swap those over for that one on there and the positive one on here, I get 700 millivolts, which is the actual photodiode forward voltage drop. So the photodiode is alright, but the CD laser diode is blown in this. Okay, so that drive is no good. I changed the laser diodes, but I'm not going through that now. I'll do it on a different video. And so this is the area we're looking at in terms of the drive circuitry. Okay, so the first thing to do is to check your looms to make sure these are moving backwards and forwards with the CD laser head as it tracks the CD, and you can get stress factors in the cables. So inspect them carefully and buzz out the cables. If you get some sort of intermittent, you move it and it's working, it goes wrong again, then you might have a stress fracture in here which is intermittent in the cable. So you do have to wiggle them about and be fairly persistent in checking to make sure that all these cables are connected properly, that there's no cracks or breaks in the cable or bad crimps. And also make sure when you plug them back in that sometimes on these Molex housing the crimp can push out when you push the connector back in. If you don't notice, you can get the bad connection, which will drive you around the twist basically. So looking down into the drive circuitry, there are several things you need to be aware of. The drive voltage for your laser drive diode is controlled by this transistor and this capacitor in the circuit of a constant current driver circuitry. Now, I've already diagnosed this one with a shorted laser diode, but this transistor was also gone. That's got a ident on the top of K3N, which is an MMBT 3906. It's just an ordinary PNP general purpose transistor. Okay, there's nothing special about it at all. That's the collector, that's the emitter, and that's the base. So when it goes through that cycle of turning the actually, when I put the new CD drive in, I'll show you the voltage you should expect on there. There are also bad solder joints. This component here, if you remove it and check it, because sometimes they do go low, is that the heat from the soldering iron will make it come back to life. So you take that component off, check it with your meter, it reads 47 microfarads, put it back on, hey, the thing's working. We thought, hold on a second, what's going on? Of course, by desoldering this, you've boiled up all the electrolyte inside here, and maybe there's a bad connection inside and you fixed it. And it's quite common on these CAN type capacitors. If you pull one out and it reads okay and you put it back and the thing's working, it was faulty and it's dried out probably. I can demonstrate that resurrecting those from the junk box just by heating them with the soldering iron, but it won't last long afterwards. Okay, so check for solder joints around here. I put a KSA 1298 in, which is another general purpose one, but it's just the same. And check around for dry joints on here. There were a number of these. Some of these I've seen have had bad connections, solder connections, and you can see that generally when you open up the unit and you look at some of the solder joints. You can see kind of they're grey and frosty, and it hasn't reflowed when it's gone through the temperature profile in reflow. These are stuck on with paste, solder paste, and then it's put through an infrared oven and reflowed. And if the temperature profile's not right and they haven't set it up correctly, or the paste is a bit off, you sometimes get very sort of porous grey soldering, in which case you might need to inspect these carefully with a spyglass. And sometimes the only way to do it is just to gently try and move the pins, and if they are not fixed on, you'll see them move, and that's much easier most times than looking at it. Alright, so anyway, what was wrong with this transistor had blown, and I don't think that was the cause of the laser diode. I think the laser diode went and then this transistor was damaged. It wasn't totally short, it's just the HFE, the gain was way down. Alright, so yeah, check around here for soldering, change that cap, change that transistor, check your wiring, and also obviously check that you've got 5 volts on these. 5 volts on these. The power for this comes down from this rectifier down here, LN317. Sorry, no, 78L05, I think. It's a 5 volt 1 amp rectifier regulator. So you should have 5 volts on these various smoothing capacitors. You don't see 5 volts. And also there's a 1.7 volt supply for the chip as well. This chip is well documented on the internet. It's available, and you can see all the pins down this side, supply pins, and you can look those up and check the actual supplies if you've still got problems. Alright, but generally it's to do with the laser supply. Now I'm just going to go to the cupboard of plenty and pinch a CD drive out or something. Hold on. Yeah, so I've just found an old Bose Music LifeStyle. I don't know if the CD drive is any good. Let's just check the diodes okay. Check the laser diodes are okay. So we're on diode forward voltage drop mode. So comment on there. So if you put your negative meter probe on the center pin, if you like the middle pin, you'll get. Okay, so with the negative probe on the middle pin, we're getting 0.7 volts forward voltage drop, which is great. Now if I switch over to keep the negative probe on the center pin and go the other way, and we've got 1.49 volts on the actual laser diode. So there you go. So it's working. So the laser diode is giving me 1.49 drop. That's about right, I think. So I'm happy with that. That diode is good. I don't know whether the rest of the mechanism is good or bad. We'll find out. We might have to rob something off it to make it work, but we'll see. Okay, so we're back to where we were. We've got the new, or the replacement drive in. Let's just go like this. I'm putting the vein back into the vein switch. And there you can see a clear red light, and that's with a normal video camera looking straight down the barrel. If we go back into night mode again, night mode. So we're in night mode now, and I'm just saying, you can't see that red very easily with your eye because it's right on the edge of the human response of vision. But you need to be careful, because if you get your eye close to it, it can focus onto the back of because it's a parallel beam of light which will be focused onto a spot on your retina, and you can damage the cells in your retina. So don't look straight into it. But this is the UV mode, not UV, IR, night mode. Ready? You can see it is quite a bright light in infrared. So that's the laser working on this now. So what we can do is just get hold of a CD. Let's go back out of night mode, otherwise I'll blind you all. Alright, so let's stick Leanne on. Down out of the way. This won't work if anything's rubbing on the disc. Put a bit of tape across the top just to make it rotate. If you put the tape too close, it'll tip it, so you want to stick it in the middle to make a fix, and then tack down the outside, and it usually works. So let's see if it will rig the disc. Looking good. Yeah, it's playing. Look, you can see down here. Here playing. So I usually mass up a bunch of CD drives and then change the laser diodes in them, because it's normally the laser that's gone, and often it's the drive circuitry is not right, or when there's dust it drives the diode harder in some where they've got a dynamic diode drive circuit which has not been properly designed. you get a dusty lens, it can't focus, it drives the diode too hard. And if the dynamics of the actual servo circuit which drive the diodes, I mean, some of them are very simple, they're just a simple constant current, but some of them are closed loop based on the actual feedback it's getting from the photo sensor. So it's playing now, so that's fixed, okay? So I hope you found that interesting. Oh, there's one other thing we can do, isn't there? Yeah, I forgot about that. Let's stop this. That's a good guess. Stop. Stop. There you go. Pull the N off. Oh. So what we can do is just show you this because it's fun. We've got our Spectro Radiometer, which we developed for a plant application for growing plants. Here. Right, so I've got Spectro Radiometer here for measuring laser diodes and things like that, and we developed this for plants actually, but it can be used for this. There's the input there, and if I just hover that over the input to the laser, from the output from the laser diode, if I can get it in the right place, and press source, and then actuate the disc. There you go. So that's what we got. We got a huge peak. This stuff here is just from the office. That's not coming out the diode. That's just bouncing around in here. But we've got a peak at 787. So which is this would be looking pretty. 660 would be looking really deep, sort of real crimson, Victorian, pawn red. You know, deep velvet red. And it gets less and less. And your response of your eye goes down like this, down here. So here you would see probably 10% or 5% of the 660 light. So the 660 light can be very bright. Then down here your response is very low, and 787 it's almost rolled off completely. But you could saw how bright it was in the infrared camera. But you just see a little inkling of red light, a little twinkle of red light. But don't put your eye up close, otherwise you'll get more than you bargained for. All right, so I might find it interesting. So it's an infrared laser diode. It's definitely working. It was the diode blown. But check those things in future. And just to recap on these, you need to, if you change the CD drive, turn the lights back on so we've got some illumination. Yeah, if you do the CD drive, then change this cap and change that transistor, and check carefully the solder joints on these. Very carefully. Turn it over and check the solder joints on the other side of the board. And you should be alright. The controllers themselves are pretty reliable. I think I've had to change one of these two in the past, but usually nothing happens. You don't get any hunting or searching. The power supply is there and there's no actuation for the motor. The motor's not going around. You know it's one of these three chips. This is the drive amplifier chip that drives the coils for the actuator for the focus. So if you've got no focusing going on and you've changed the CD mechanism, then have a look at the supply voltages around there, and also check the clock frequency. All right, so I hope you found that interesting. It's just a really quick one just to fix a CD drive in a LifeStyle System 5. The assembly is the reverse of the disassembly. The only thing you've got to work out is that this clip goes in there. All right. So that's the CD. Don't forget to put, when you screw it back in, don't forget to put that clip in. But otherwise, you're golden really. And I hope you enjoyed that. There are other Bose LifeStyle repairs, and they'll be adding more because I'm retiring. So I'm just passing on. Pass it on, boys. Pass it on. If you liked it, then subscribe down in that button down there and leave me a like, because I like likes. And if you're repairing yours, if you've got any questions, I'll try and help. And good luck.